Leveraging GenAI and Business Operations, a virtual conversation hosted by the Loyola University Chicago AI Business Consortium in combination with our friends from Microsoft. Welcome. Thank you for taking time out of your busy day. The objective for today is to provide a very, very brief introduction and overview to GenAI. Because we find that there's a lot of confusion out there about that. That's gonna be followed by a presentation from the Microsoft team that's developing their scalable conversational supply chain assistant framework, which I think you'll find fascinating. They've walked me through some of it, and it's very enlightening how they're trying to bring this technology inside Microsoft. So the agenda for today, and it's only an hour. I'm going to talk a little bit about GenAI and the size of the market itself. Then we'll go into the Microsoft presentation by Anil, Aswin, and Karthick, and then hopefully we'll have some time for Q&A. Preference would be, if you don't mind, put those in the chat, and I'll try to get to them as the Microsoft folks wind down. So with that, again, thank you so much for joining us this morning. I often find when I give presentations that there is quite a bit of confusion about not only GenAI, but machine learning itself. And so I want to present a very, very simplistic overview of these two topics. For some of you, this might be extremely repetitive, and for that I apologize, but for the rest of us, to establish sort of a fairly basic level of knowledge. And so as we start with, what is in fact machine learning, a handy definition is functions that improve their performance of a prediction task with experience, which is illustrated by a very simple formula, y equals f of x plus e, which is our error term, which basically says we're training an algorithm or a function f to learn the relationship between x and y, our independent variables, and our predicted outputs based on experience. And so with that, as we then start to look toward a fairly simplistic definition of GenAI, we can think of that as a machine learning model that creates new data rather than a generalized prediction algorithm that's doing regression and classification predictions. So a GenAI system is one that learns to generate objects that looks like the data it was trained on, and it's simply text prediction. But due to advances in compute and algorithms like transformer algorithms, this ability to generate has vastly improved. And as one tries to get a basic understanding of how this works, I mean, how do you get from inputting a prompt to getting, a pretty reasonable or decent output from ChatGPT or any of these other things? It's helpful to just think about the math behind all this, and that human language has an inherent structure and detectable logic with grammar, patterns, similarities. And what happens is these deep learning models or large language models are exposed to vast data sets that uncover these statistical relationships within language. And so at the end of the day, what we're doing is we're harnessing computational power that enables an LLM to discern logical mathematical patterns around communication, and through advanced algorithms, be able to focus attention on different words and contexts of words. But I always like to remind people, when they particularly start to think about these things as understanding or or reasoning, et cetera, et cetera. That's not the case. It's all about math and probability, and that's important to understand. And so within this huge corpus of text, words, sentences, we find certain dependencies of these words, and it's these reoccurrences that helps the model understand and cut text in statistical chunks that have predictive ability. Importantly, we're able to also now use self-supervised learning as well as unstructured text, which vastly improves the amount of applications and automation that we'll demonstrate by our friends from Microsoft in a minute, so that we could bring knowledge management, knowledge enhancement to fields that before were not susceptible to that, like the legal field, like the accounting field, et cetera, where we now can use unstructured data and apply advanced algorithms to solve different problems. And so just sort of how this looks very simplistically, again, we go back to the simple formula I showed you for machine learning earlier. In a traditional machine learning environment, you're inputting labeled data, and from that, you're doing an output prediction, regression, or classification prediction based on those supervised labels. And in a GenAI model, we're taking unstructured content, and we're able to output new content. In terms of the market size itself, the predictions are really all over the board. And this particular projection was put together by a company called Statica. They estimated the global AI market in 2030 at about 2 trillion. A bit more recently, Bloomberg Intelligence estimated the size of just the GenAI market, which is a subcategory of AI, at as much as 1.3 trillion by 2032, growing at a fairly robust 42% compound annual growth rate. I wanted to just share this last couple of charts with you because I find them extremely helpful. And this is a chart produced by Goldman Sachs in March. And basically what they're saying is globally, 18% of work can be automated by AI. And for advanced economies, i.e. the US, for example, that number could be as high as 25%. I don't know if the market's going to be 2 trillion or 1.3 trillion, but I do believe this number, that a lot of knowledge-based tasks will become automated. And again, we'll have a great example of how that works here in a couple of minutes. I wanted to just point out one last thing before I hand it over to our friends at Microsoft. If you're not familiar with this report that came out in September of this year by Harvard, they worked with folks at Boston Consulting Group, and basically they separated a group of consultants into an AI-enabled group and a non-AI-enabled group. And as they analyzed the performance, what they found was pretty interesting. So AI significantly increased performance and quality for every model spec, increasing speed by more than 25%. Performance is rated by humans, not machines, humans, by more than 40%, and class completion by more than 12%. So I think this is a pretty powerful statement about how knowledge industries, again, law, aspects of accounting, aspects of supply chain, marketing, will be pretty much impacted by what's happening in GenAI. One thing that they didn't report in this particular study, but I heard one of the authors comment on, was they also found that the AI-enabled group was less creative in their solution approaches. and whether that was due to a dependency on the algorithm or what was not really classified. But the point is, you really need to think about these tools as enhancements of your work or the people that you work with, enhancements to their work rather than replacements. Because again, at the end of the day, it's just mathematical computations. And so with that, I am going to turn this over to Aswin and Karthick from Microsoft.
Okay. So thank you for the great introduction, Stephen. And I think you covered a few slides that we're going to hit again in the coming steps. So I think we have a little more of a crystallized agenda within a larger agenda. Stephen spoke you through. So this is what we plan to cover. We plan to kind of give you an introduction on who we are, what we represent, which org we represent, and why are we here to explain over the work that we did. Give you a brief introduction, which is a very much more crystallized version, not an as detailed version as Stephen gave you about, or what is GenAI, what are some prerequisites that we experienced from building the solution out? And what is the opportunity that is in front of all of us and also was available for our org? How do you interact with this particular technology, which is the foundational models that is in the prompt and the training element? And then you have the architecture, a brief overview of the architecture itself, and and the vision statement and the plan that we have for this tool. Now, moving on to the first slide, who are we? So we are part of the Microsoft Devices organization, which is all the hardware that Microsoft puts out in front of you, which is some examples of those are Xbox gaming consoles, Surface devices, which are laptops and notebooks. You have all the PC accessories, mice, keyboard. We have a Surface Hub, which is used for which are used in businesses for as, uh, uh, as representation screens. We also have the HoloLenses, so which is all the AR and augmented reality devices that we offer. So our team supports the devices supply chain all the way from manufacturing to when it reaches the customer, and in some cases even returns. So a lot of times customers have returns, and that's also an extended offering that we extended as a team. And both Karthik and I, we were tasked to develop and use this new generative AI technology, which has been available to us for about 2 years, to come up with a good application and solution for this technology. And we were at it for about 2 to 3 months. And what we will speak through in the coming slides is what we took away from this particular learning. Right, Karthik, if you click through to the next slide. So we begin with a very similar introduction as Stephen gave you, which is what is the difference between all these different terminologies. I think we've heard a lot of terminologies over the last few years: LLMs, GPT. What do all these represent? What do all these mean? Briefly, is what we want to cover here. We begin with what is AI. So AI is something which is misunderstood in a lot of instances and cases, and even in my experience. AI is the overarching concept and it's a broad field. It does not necessarily mean very complicated machine learning, regression model, algorithms. That example of one is what Stephen showed us in that equation. AI in some cases are simple if else statements, right? It could be a bunch of different if or if this happens, do this or do something else. A combination of that, if you string it together, that is also something you refer to as AI. So a simple application of this in everyday instances in companies is a simple root cause analysis tool or built on Excel. That is also essentially a generative, an AI tool. Um, it basically mimics human behavior in if you crystallize it. Now, moving on to the next level, which is a subset of AI, which is machine learning. So this involves creating equations like how Stephen showed us. So it uses regression modeling, it uses time series modeling, several different complicated techniques to give us different outputs. So there are several applications of this around us. All the recommendations that we see on Amazon Prime, or all the recommendations that we see in the shopping experiences that we have, are applications of machine learning. Now, moving on to deep learning, which is a subset of machine learning, this is where you have neural networks, which is very similar to how our brains function. And they create complex, they help identify complex patterns within the data that is applied. So it, in some essence, kind of becomes more powerful when you go to this level of AI. Examples of that is the self-driving cars that we have around us. All this computer vision-based application like image processing, video quality analysis, generation of images. All these are, in some essence, deep learning applications. Now, generative AI is a subset of deep learning. So it's a branch of deep learning where you use these neural networks called large language models, which are LLMs, right? So a lot of these a lot of these neurons come together to form a large language model. So these deep learning models it can generate, we've seen all of it around us. We can generate images, it can generate text, it can create a lot of content on the examples and the data that we supply to it. There are several examples of it. ChatGPT is one. Bard is another from Google. DALI is another one that we have for image generation. So we have a lot of applications and examples of this all around us. If you click through, Karthik, yeah. Now, briefly, we're talking through the use cases for these in the current industry landscape. These are some of them. We are not covering everything that it can be used for or it is used for, but these are some that we crystallized out. First is customer operations. So I think all of us on an everyday basis sometimes go for any sort of support to a platform, to a website. What it inevitably sends our way is chatbot, and these chatbots tend to give you a poor experience for a lot of reasons. So they tend to be very logic driven and very specific in its programming technique. This ends up creating a very bad experience in a lot of instances where you are inevitably routed to a physical agent who has to solve this problem for you. So what this generative AI really extends out to all of us in the current scenario are foundational models. These foundational models, we'll go in more details of what foundational models mean and how it can be used, etc., in the coming slides. But what a foundational model gives you is it takes away a lot of the engineering lift which needs to go into this creating this basic logic driven programs which can take a user input, transform that into something meaningful before we can use it to get some sort of information out of what you're trying to service the user, service the customer. Now, this baseline model that is extended out to all of us eliminates the initial engineering effort which would be required to build out something like this. So there are multiple applications for it. It can be an automated chatbot. It can also enable an agent to be better at his work. Now, moving on to a second application, which is in marketing and sales. There is significant application for it in advertising, in marketing industry. It can help create personalized content, personalized marketing strategy to the extent of a customer level. It can analyze tons of data, unstructured data of a customer, create tailored marketing campaigns, etc., on the basis of these analysis. Now, and another place where we see it getting applied is the software engineering, where it's really enhancing the productivity of an engineer. So our team, to be very fair, leverage GitHub Copilot. It essentially decreases a lot of the initial code writing aspect of it. So what GitHub Copilot or this technology really enables is gives you a baseline of code where you work with, and then you develop on that code. So these baseline codes that we talk about are kind of repetitive, and you don't necessarily need to be investing energy and thought into really writing that. So it essentially eliminates that whole process of going through that and developing that particular baseline code. Then there is the element of testing. A lot of people are using this for testing, really, the programs that you build out. And finally, this is something I think all of us have come across, which is in entertainment and media, where people have used this to create content. I recently came across a particular short movie which was completely written using one of the generative AI solutions that we have. So a lot of interesting applications, a lot of new applications in the future as well. Now we go into a bit of what has our experience been on this journey. So we've been leading the development of this solution for Microsoft devices, and these are some of the things that we took away and felt were requisites to really enabling an enterprise integration, right? So one could be the fact that a lot of times whenever something new is made available to all of us, uh, there is always a push, a top down sometimes push to really go after that technology. So it could be generative AI now, it could have been deep learning a few years ago, it could have been whatever, like quantum computing. You have this buzzword, and everybody is really going after that particular technology and buzzword, right? So, but we as a team have have been investing in data and infrastructure over a period of time. And these are basic prerequisites for really getting there. And the picture to the right is kind of self-explanatory, where you have elements of data quality, you have elements of data literacy, you have elements of analytics maturity, which is really required to enable something like this. So you need experts across domain experts, you need software engineers, you need data scientists, all to work together to come to really stand up a solution like this. Karthik, if you click through. Now, this is the second element that we talk about, data maturity. If you click down, double down on that, what we like you to focus on is the top part. The second part, the bottom part of the slide can be looked at a little later, but let's focus on the top part. So sometimes in 2015 to 2017, there is this is most of the data landscape and data maturity most organizations had, even large organizations for that matter of fact, where you had a lot of teams and a lot of the data and a lot of the analysis was managed on Excels. And they moved from there, and then you had these siloed, decentralized data, data repositories which are built out by specific sub-organizations or some areas. You would have these some areas really putting a lot of effort, maybe investing a little bit in cloud, maybe investing not, maybe they are having their own infrastructure where you have somebody bringing all the data together and they spin up a bunch of reports, which is shown to all of us. Then they go past that decentralized data existence to one off where an investment is made into a data lake or data warehouse, or some sort of large data investment. So when you make that investment, the next logical step is to decentralize all this data and pipe all this data together into a single point of contact, right? And now if you look at some of the points to the analytics each of these enabled, they don't terminate at that, they live on from there, right? So you bring this decentralized data, it enables descriptive reporting, then you have several different applications of having all this data available to us. So these are kind of supply chain relevant, but it holds good for every industry. They have different types of applications for data science, they have different types of applications for optimizations. Then when you look past the centralized data, you get to this existence of a complete data-wide transparency and visibility across all the functional areas that you possibly manage. And that really opens up a lot of interesting opportunities for you. Like, in our case, something called digital twin simulations, command centers, ability to optimize on several different models, several different supply chain strategies, network design. So several different things are made available to to you when you come to this state. So we feel that this level of maturity is kind of a good prerequisite to really help you go after something like this. Karthik, if you click through once. So this is where we are. This is where we were when we were on this journey. So we have about 800 TBs of data. We have like 500 plus analytics products, which are split across the full spectrum of descriptive, the predictive and prescriptive, and sometimes even other different solutions. We have about 20K impressions per day on these solutions across the team. And this is when we are going after an AI-driven virtual assistant, right? Karthik, yeah. So this is the opportunity essentially, which is we have all this data available to us in the centralized repository, and we have these GPTs, these foundational models, great foundational models, and what we plan is to what we plan, and we've kind of enabled is an AI assistant which leverages both of these and gives a lot of insights to the users. Now, now let's here we are going to really talk about what these foundational models mean and how you can interact with this foundational model to build your own enterprise copilot, right? So a foundational model essentially is what you get offered in the form of a chat GPT 3.5 or chat GPT GPT 3.5, not chat GPT, sorry, GPT 3.5 turbo or a GPT 4, which is made available to you by OpenAI. Or it's not limited to OpenAI. A lot of different companies are putting out interesting foundational models which you can leverage. So these foundational models are trained on data across a lot of different domains, but it's mostly internet data. So when you bring such a model on to your ecosystem, it does not necessarily know the context of the business that you work in, the terminologies that you use, the nuances of how all the systems interact or how all the processes work. It does not know the key performance indicators that matter to your leadership. So all these need to be taught to this or explained to this uh, to learn from. So there are several different options for you on how to interact with these models or to train your own model. So these are the four different alternative from what we've identified. One is prompt engineering, right? So first one is the most rudimentary or the most common interaction, which is when all of us go on ChatGPT or any of these platforms, you ask a question, you might or might not get an answer. You tweak the question to get to the answer, right? So that's essentially prompt engineering crystallized. So here, what we end up supplying is a guardrail or I would probably call it an example for it to help you get to the answer. For example, few shot learning is a terminology that is used for prompt engineering, where we give it a small example of the particular task that you want it to do for you, right? And it learns from these specific examples, and then it can use that example and give you similar output when you give a similar question to it. So that's essentially prompt engineering. If you crystallize prompt engineering, and it's also about telling what I went when what I spoke through a little while back about your domain. What does it mean? What is the role that this LLM has? So it's a pretty elaborate bunch of instructions which the model will use every time it runs to give you an output. Now, going on to the next and a more advanced technique to do better prompting technique, it's called retrieval augmented generation, or RAG. So what RAG essentially does is it it takes more contextually and relevant specific examples, supplies it to the foundational model, and it's kind of tailoring it to the request of the particular ask, right? So There are different ways to do this. A lot of times there are vectorized, meaning large data sets which give instructions, and you pick up portions of the instructions to say, use this example to give me this output when this kind of question comes your way. Now, the third technique is training it on a specific data set or examples to to tailor it to respond for specific tasks. So you can imagine this more like a machine learning model where you give it a bunch of examples, it learns from that example, and it's pre-ready for you to consume every time you go on. The ones before it, prompt and retrieval, would be something you do on the fly when you leverage the solution. And the final one is training your own foundational model, which is you investing engineering effort and building your own ChatGPT, right? So if you click through to the next slide, Karthik. So what we show here are the benefits and or drawbacks that each of this offers you, right? And inevitably, I'm sure even in the previous discussion, you would automatically think the best solution is training your own foundational model. But if you simply understand how difficult it would be is very visible in the visuals that we give here. The complexity is significant, the cost will be significant, and ease of updating something like that would be pretty abnormally high, right? So what you are left with are three different real alternatives when you have these foundational models available to you. One is prompt engineering, which is definitely your uh, cheapest, but maybe not the most accurate approach. It might also not be the most scalable approach because you are limited on how much of information you can pass for into this foundational model every time you interact with it, and that really will prevent you having, say, a enterprise wide rollout. A company wide rollout would be pretty difficult using only prompt engineering, but it would be very easy to stand up. The cost would be significantly lower than some of the other techniques that we would use. The the other one is the retrieval augmented generation. You have much higher accuracy, is definitely more scalable. The complexity element of it is definitely increasing, and the cost element is also definitely increasing. But it's still not something that you can't. It would not be a lot different from prompt engineering. And coming to fine tuning, this would be like a very customized model for your application, but obviously it comes with a higher cost, and it also comes with the additional complexity of having a more data science driven team to really help you do this exercise. I think if you click through, I'll hand it over to Karthik, who will speak us through the architecture and take us further.
Okay, thanks, Aswin. Could you hear me?
Yep.
Okay, so I think let me just divert the topic. I think we are talking about all the concepts, fundamentals from the generative AI. Now let's just turn back and then see how an user or how an organization or how an developer can go and implement kind of a solution for their use case by using this LLMs or an ChatGPTs or GPT models. So basically, think about this as an kind of an high-level architecture. For example, what are all the building blocks which an kind of an person needs if he wants to leverage an GPT and build his own AI assistant on top of a business data? So let me take you through the flow with how a user interacts so that it will make more sense and how we are approaching this architecture in our organization. So first two blocks are self-explanatory, which is a user who comes into an kind of an interface or an AI assistant where he asks some question. What happens next, right? Basically, there is an orchestrator which sits between our system and also the user. So what it does is it takes the user information and it generates an kind of an uh, condensed or a composed kind of an gist from the user question, and it sends into the system. The system here, what we put as a box, which is the integral part of our architecture, which is the GPT, where we use our GPT model, and also we use a LangChain over here. I will quickly go over how we are leveraging this, what it is doing, and how actually the things are being done in our kind of an AI system in the real world. So orchestrator gets the user information, user question, or an user ask, and it transfers to the system. So here, once the orchestrator transfers the user question, LangChain takes the user question. There's a LangChain here. You can think it as some kind of a wrapper, which is kind of an acting between an orchestrator and an GPT models. So what actually the LangChain does is it takes the user question, it understands the user question, and it finds, okay, what is the best model I can use in this case, whether it is a GPT 3.5 or a GPT 4 or different models. So it takes that user question and also it identifies, okay, here's the user question. This user question is corresponding to this business use case. It identifies that and it gives all those information to the model, which is a GPT 3 or 3.5 or 4 here in this case. So what this GPT models does with those information is it knows what data is needs to go and hit, and it knows what is a user question, and it knows what it needs to do next, right? So what it actually does in this case is it takes the user question, it understands the user question, and also it understands what is a source system, and it converts the natural user question into an system understanding format in a kind of a queryable format. Then it sends into a search service, which you are seeing as a cognitive service over here. So that cognitive service goes into the source system. Either it is in a real world, it can be on OneDrive files or on database systems or on storage or in any case, any form of kind of an information which is sitting. So this service with this search service goes into that source system. It puts the query on top of it, gets the result back, and gives it back to the GPT models. So now what GPT is doing is it asks for some relevant information for the user question. It gets all the information. Now what this LLMs or GPTs will do is it gets all the data and it summarizes or analyzes the data according to the user question. If user is asking for analyze so-and-so data, it takes the data and it analyzes for the user. And what it does is after it analyzes, after it summarizes the answer for the user question, it sends it back to the orchestrator. So now orchestrator got the answer which it needs to give to the user. This orchestrator goes and rephrases it in a user-friendly manner and gives it back to the user. So this is in very high level how the architecture works. But the integral part which I wanted to insist here is this box which you are seeing over here, which is the LLMs mainly. So this is what it is doing. All the beauty of all this researching the data, understanding the data, doing an natural language processing, etc., and getting the results back to the user. So with this, I need to just move to the next step where I wanted to show you with this integral GPT how the life looks now, and then without this how earlier we are looking like, and what it takes to build the system, right? So with our experience, this is what the criteria which we came across. So if you see this, without this building block, right, without the generative AI available, our effort is very high because we need to go and build this whole bunch of logic which OpenAI gives, right? Getting the data, going and fetching the data, summarizing it, analyzing it, doing a research, doing an ML on top of it. Everything we need to custom build, right? We have a data science, data engineers, software engineers who goes and builds this, right? That is where we see without generative AI earlier, there is nothing like this GPT-4 over here, but we go and build customly. So that is where effort is very high. And also, if you see this, to build this end to end by ourselves, we need a more software engineering resources, we need a more data engineering resources, we need a more data science resources. But after we got this generative AI, right? So the effort is very minimal because I think it is not high because you need not to build this bigger picture here. You just take it from OpenAI, plug it, and pay for what you are using for it. That's how the world is changing right now. But if you see the resourcing, you don't need much of data science in this aspect because the model is already available for you to use it. As Aswin mentioned earlier, you need to just order it to how to perform with the data. That is what you need to keep on doing, a prompt or fine tuning or a RAG or retrieval augmentation. All those things you need to do. So there is no model building as such we are doing. So if you see this compared to with and without, we see lots of difference in the effort and also a resourcing skill set. So it's drastically reducing and also drastically reducing the velocity, how quickly we build the systems. So with us, I will take you to the visions. Okay, we talked about how we are approaching this, and also we talked about how we implemented in an architecture wise as an end-to-end flow. Now, what we are trying to achieve out of this, right? What is our vision? So in our organization, we have a supply chain planners and channel managers, everyone. They have lots of fundamental questions every day, how our system is performing, and there are lots of supply chain related questions they need to answer every day and day out. For that, current day, they are going into lots of reports, Power BI reports or Excel sheets where they pull the data, do the manipulation, etc., and get the answer out of it, right? But eventually, we need not to do all those multiple multitasking things. Rather, we need to leverage this GPT models and build a system which answers readily and immediately. So this is how we need to. This is what our vision, and we are building this. So if a supply chain planner who is going and asking, can you please analyze the latest quarter results and summarize the key trends? So it goes to the system. It needs to get all the bunch of last quarter's data, and it needs to analyze, and it needs to give them kind of a key trends. This is what we are visioning, and this is what we are building for right now. And then furthermore, we wanted to go and do some bit of reasoning and also do optimization. So we are asking the GPT or AI assistant in this case, okay, you have a data, give me some suggestions. If I wanted to ship to an customer, what is the best way to ship it, right? So these kind of reasonings, we wanted to go and ask for it, and then we are expecting the assistant to give them very reasonable answers for us. So our intent here is, and our vision here is, we don't want to build only a Q&A agent. Rather, we wanted to use the full spectrum and the beauty of generative AI to extend it further. So that is the vision we are going through, and we are developing our product right now. And I will just quickly take you through the takeaways, and I will hand it over for a Q&A. So the first takeaway I need to just explain during our course of development and the course of implementation of this product is data privacy and security is the biggest, most kind of a takeaway which we went through, because it is a business data, business critical data, and it is sensitive. We need to make sure, or we should be pretty clear in what we are exposing through AI to which user, what level of information, how secure it is, and on the fly we need to make the security available. So that is a very critical piece and a critical takeaway which we take it out of when we implemented this, which is the data privacy and security. And then the second takeaway I need to talk about is understanding the context and nuances. I think Aswin covered this a little bit. So for example, right, all the GPT models, which is an OpenAI models, which is available readily in the market, is trained on the internet data, as he mentioned. It is not trained on your specific use case. So the complexity comes here as, okay, how you will make sure the GPT models are understanding your business context and the nuances, and giving a proper response or an absolute accurate response. So that is the biggest takeaway which we went through, and we learned over a period of time how to tune the GPT models and get the relevant answers. The last takeaway I need to just cover here is continuous learning and improvement, right? This is this AI Copilot we built. It is a version where whichever information we have on that day, we provided it to it. It is giving a response. Now, over a period of time, your business changes, your data changes, your scenario changes. We need to make sure there is a continuous learning that is put in place, and we are continuously improving the system so that it's scaled to the business needs and also the changing environment. So that is one of the key takeaway which we saw for last 4 months when we built this. There is a lots of changes in the business. We need to make sure our system and AI assistant is correctly learning and then improving over time. So, and there are some of other key takeaways. I will just leave it to just read through it. And with this, I think I will hand it over to Q&A, Stephen.
Okay, thank you so much, gentlemen. That was great. We do have a few minutes for Q&A, but before we jump in, I would also just like to introduce another team member from Microsoft, Anil Sebastian. Hi, Anil, say hi. Anil's on the aibc steering committee. He was the brains behind organizing today's event. as well as the team leader for this project. So thank you so much, Anil, for helping put this together.
Yeah, absolutely. Thanks a lot, Stephen. Hi, everyone. Very nice to virtually meet all of you. I really hope you all derived a lot of value and knowledge from what the team here has put together. This has been work that we've started about the last 4 or 5 months, and we went through so much of learning, as well as we ourselves went through a little bit of when generative AI became a big buzz. It sort of went through the hype cycle a little bit, and so um, in the last few months, we've been having a lot of learnings about where it is useful, where it is not useful, and how we can truly drive benefit from it or not, just like any other technological solution. Um, so we'll switch into Q&A, and feel free to ask us any question. We'll try to answer to the best of our ability.
Okay, well, I'm going to ask the first question, and then we'll see. We got a couple of others, but real quick, because you guys kind of went through this super fast, which is the chat bot you're developing. And let's sort of stay away from Microsoft because we don't want to get anywhere where anybody's getting into confidential stuff. But I mean, when you ask that chatbot, tell us where sales are trending from last year, or should we ship or from this warehouse, or fix these machines, or do. I mean, what's going on behind what looks like fairly simple questions, right? Between going through structured data, like what's in your inventory, what your orders are looking like, what the conversion rates, to do all these things. You made it look very, very simple, gentlemen. So congratulations for that. But I mean, maybe, and again, we don't want to get into Microsoft stuff, but just at a high level, could you kind of relate to the complexity of some of the things you're doing? Because I think it's pretty cool.
Yeah, I can speak a little through it, and I'll let Karthik or Aswin chime in if there is anything else to be added. But we have a ton of data in our data lake. In fact, we spent a good amount of our digital transformation journey just piping all the data from across our network. And we really made that a priority for the organization because we valued the value that visibility can bring. So we have a ton of data. I'm talking about terabytes worth of data. And then what we did on top of that raw data is building the right structure to bring all these together into meaningful data elements. And we spent a lot of time there as well because you need to take care of data quality. You need to have a very good understanding of the business. You need to have your business tell us how they look at metrics, how we go and compose and build those metrics. And then the generative AI wave hit us at the right time because we had really good data visibility, we had really good data quality. And then what we had to then build on top of those was we had to stitch together a bunch of data across our data lake to create these data models that then power these virtual assistants that we went and created.
I'll add a few more things to what Anil said in terms of like talking about advanced capabilities, Stephen. So there are different types of capabilities that come out of the box. Like for example, if you give a ChatGPT model a bunch of sales data, sales data for a period of time, if you ask a question like, "What are the top performing SKUs in this?" it will answer it for you, right? So there are some of these, advanced applications or use cases which this can really service out of the box. But then there are elements it does not do. So in our case, like Karthik and I, in our case, a lot of the work that we do is really understanding what comes out of the box and what is not, right? Like for some things which don't come out of the box, figure out how we can add it. Maybe it's using leveraging existing packages of different offerings, or building our own solution which talks to this assistant. So there are different ways we are really augmenting this, and we've been right now it's very trial and error, learning from attempts. So but what we put out so far has certain, quite a bit of intuitive computing capabilities.
Oh, thank you. Karthik, did you want to add to that or?
No, I think Anil and Ashwin covered it pretty much. Yeah.
Okay, great. So we got a couple of minutes for some questions. I'll start with the first one from a gentleman, Rick Chavey. Rick Chavey. Are companies actually reducing their data engineers, scientists as they introduce Gen AI?
Yeah. No, at least not us. In fact, we are investing more in data talent hiring. If I have more hiring budget, I would go and hire more data engineering and data scientists, because what generative AI has shown us is that, of course, yes, if I like the team showed on a particular slide, if we were to build the same capability, we would need if we were to build the same capability without generative AI, we would need a lot more engineering prowess. But what generative AI has now helped us is to reduce that type of work a little bit. But now we are deploying data engineers to really help us get all the data, build all the right data models, improve the data quality, improve the data visibility, so that technologies and models like GPTs and generative AI in general can leverage that better. We are also investing a lot of data science effort to see how we can build um, models that can power generative AI. So we showed you a great deal about how the GPT models can leverage raw data and answer questions. And so we are also now thinking, if we have an optimization model that tries to optimize inventory, if we have a machine learning model that is trying to forecast sales, can these models now be ingested into the GPT? So somebody asks a question around how much inventory should I carry here? It is able to go and access those models, run those models, and give you an answer back. Right. So the nature of work is slightly changing, but the investments is only increasing in the data space in general. I hope that answers your question.
Yeah,
Thank you.
it does. I'm just curious, do you see Gen AI as sort of an umbrella linking other models together from what you said? So that
I
if you're
think
optimizing and doing those kinds of things, Gen AI may not do that. It may just make it sort of standardized and better, but not optimized. But it sounds like you're trying to use it as an umbrella capability.
we are testing out that hypothesis. It's not fully proven yet, so I don't want to say that it is how we are going to be using, but we are testing that hypothesis. Um, because if you just think about large language models in general, it's basically like at the root of it, it tries to guess the next word, right? It's a sort of auto completion on steroids. But we started thinking about it in some different dimensions as well. If we are able to build an interface where it's able to look through different sorts of data, can it also look through different types of models and different types of agents? And that's what we are trying to test out.
Cool.
To add to Anil, I think that is where if you see our architecture, I think that is where the orchestrator comes into picture. It decides which model I need to use it and so on, so user question. So that decides which one I will go and pick and then get answer.
Thank you. And then we have a question from a gentleman, Dan William. Can you give examples of where AI was and wasn't useful? And he uses the word AI as opposed to Gen AI, so I suspect it's a broader question.
Yeah, I want to just check, Daniel, if you're referring to overall AI. AI is a very broad umbrella of various types of technologies within it. And if you're speaking specifically with Gen AI, we have some good insights on where Gen AI is probably not the best, or where it has to be
Yeah,
somewhat
and this is Dan,
altered.
and I was just responding while you were talking, where you said you were testing
Yeah.
your products and where it was and wasn't very useful. So if I worded the question wrong, I apologize. But I'm just wondering where it works and where it doesn't.
Yeah. Ashwin, you have some perspective on this?
Yep, we could try to answer that. So at least in our experience, we are trying to do optimizations. Like for example, we are trying to use generative AI Okay, I'll take a very simple example, like a traveling salesman example, or where do we ship something to RDC, which is the most cost optimized way to do it? The existing frameworks that are available to us. So meaning our team puts zero investment into really building that out. We're just trying to use generative AI to do this for you. We haven't had a lot of good results, right? So we are really figuring out how to get there. This is what we can give as an example as of today. So that's one of the capabilities that we are really trying to achieve. But at the same time, where it's good at, it's very good at converting uh, um natural language or text to a SQL, right? It can happily take a question like, for example, then you have a question about what is something today, or what is the situation for our business as of today. You can take that question, convert it into a SQL, use the SQL to get the data from your lake, crystallize it in a good form, and give you an answer for it, right? So that's one place. That's the first application we have really gone after as well. Karthik, anything else in
No,
terms of that example?
the optimization is a piece I wanted to talk. I think you covered it pretty.
But that's what it's today. But we might say something tomorrow, because we are
Yeah.
really experimenting here. It's a pretty new space, even for all of us. So it's very exciting. A lot of things are happening. A lot of new developments are there every day. New frameworks every day. So we are really learning as we go. But so far, we've had little less luck with optimizations.
All right, everybody. No questions, but I think we gotta let everybody get back to work. So I just really like to thank our friends from Microsoft for their presentation today. Karthik, Aswin, and Anil, thank you so much. I do find it fascinating that one of the more advanced technology companies in the world is still, quote unquote, experimenting with this. And it kind of just hopefully puts it in perspective to everybody that this is still very much an evolving technology that we're all learning about. And let's not get too caught up in the hype, because we all have a lot to learn. But with that, thank you all for joining us. We'll have our next distinguished lecture series in January, and we'll be sure to invite everybody to attend that. So again, thank you so much for presenting today, Karthik, Aswin, and Anil, and thank you all for joining us, and we'll have a great Thanksgiving, and we'll look forward to seeing you again soon.